Good morning, good afternoon, good evening. Welcome to Max Makes Maths Easy. Today we are going to do a question on calculus. We're going to do a question on calculus, and calculus is divided into two, that is differentiation and integration. Differentiation and integration. Today we are going to do on differentiation, which is the last topic in Form 4, I think. Let's dig into our question that reads: the displacement x meters of a particle moving along a straight line after t seconds is given by x is equal to t cubed over 3 minus 3t squared plus 9. And our first question is determine the values of t when the particle is momentarily at rest, that is 3 marks. Momentarily at rest, that is 3 marks. The second question is the values of the displacement x meters by the time the particle comes to rest. The second question is determine the values of t when the velocity of the particle is negative 5 meters per second. Negative 5 meters per second, that is 3 marks. And the last question is determine the acceleration of the particle at t equal to 2 seconds. So the first question is the values of t when the particle is momentarily at rest. What do we mean by when the particle is momentarily at rest? Momentarily at rest means the velocity is equal to 0. What is the velocity? The velocity is the derivative of the displacement. Let's say if displacement is equal to y, if the displacement is equal to y, then the velocity is the derivative of y with respect to time, but it is with respect to time. So the velocity is the derivative of the displacement with respect to time. So here we have given the displacement as x is equals to t cubed over 3 minus 3t squared plus 9. So the velocity v is equals to dx dt. So dx dt is equals to d of x, which is t cubed over 3 minus 3t squared plus 9 with respect to time. So that becomes the values of, we are told to find the values of t when the particle is momentarily at rest. So the derivative of x with respect to time, that is, I hope you know how to do differentiation, that this t cubed divided by 3 becomes, we drop the power, that is will be 3t, then we minus 1 from the power, it will become 3t squared divided by the 3, minus, we do the same, we multiply the power with this coefficient, it will be 6, then we subtract 1 from the power, to be t, then if it's a constant it becomes 0. So our answer becomes t squared minus 6t. So we are told to find the values of t when the particle is momentarily at rest. When the particle is momentarily at rest, the velocity becomes 0. So t squared minus 6t plus 0. So it will be, or is equal to 0. Is equal to 0. So it becomes t squared minus 6 t is equal to 0. That becomes, when we factor out t, it will be t into t minus 6 equals to 0. So the values of t is equal to 0, then t minus 6 is equals to 0, where t is equals to 6. So the values are t is equals to 0 and t is equals to positive 6. Those are the values of t t when the particle is momentarily at rest. So our second question reads, the values of the displacement x meters by the time the particle comes to rest. The values of the displacement x meters by the time the particle comes to rest. By the time the particle comes to rest, t is equals to 0 and t is equals to 6. So our displacement is x is equals to t cubed over 3 minus 3t squared plus 9. So when the particle comes to rest, t is equals to 0 and t is equals to 6. So we have to replace t with 0 and replace t with also 6. So it will be 0 cubed divided by 3 minus 3 raised into 0 raised to 2 plus 9, and this becomes 9 meters. When the t at t is equals to 0 and at t is equals to 6, the solution becomes 6 cubed divided by 3 minus 3 into 6 squared plus 9. This becomes 6 cubed, 6 raised to 3, that becomes 216 divided by 3 minus 6 squared is 36, so 36 times 3 minus 108 plus 9. So is 216 divided by 3. That becomes 72 minus 108 plus 9. Then 72 minus 108. 72 minus 108 plus 9. That becomes negative 27 meters. Negative 27 meters. So the answer is 9 meters and negative 27 meters. This negative 27 meters just means the particle goes in the opposite direction. So it is negative 27 meters. Yeah. So we're again told to determine the values of t when the velocity of the particle is negative 5 meters per second. So we found the equation velocity is equals to dx d over dt, and we find dx over dt here as a t squared minus 16. So we are told to find the values of t when the velocity is negative 5 meters per second. So negative 5 is equals to t squared minus 16. So t squared minus 16 plus 5 is equal to 0. So we are going to use a quadratic formula. So it says t is equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. So our b here is negative 6. So negative 1 times negative 6, it becomes 6. 6 plus or minus square root of b squared. B is negative 6, so negative 6 squared is 36 minus 4 times a is 1 times c is 5 divided by 2 times 1. That becomes 6 plus or minus square root of 36 minus 4 times 1 times 5. That becomes 16 divided by 2. That becomes 6 plus or minus square root of 16 is 4 divided by 2. And the values of t becomes 6 plus 4 divided by 2 and 6 minus 4 divided by 2, and the values of t becomes 10 divided by 2 is 5 and 6 minus 4, that is 2, that is 1. So t is equals to 5 and t is equals to 1. Let's go to our next question that reads, determine the acceleration of the particle at t is equals to 2 seconds. So if we are given velocity is equals to dx over dt, then our acceleration becomes d over dt squared. This just means the second derivative of x. The second derivative of x simply means the derivative of the velocity. If displacement is x, the x is equals to displacement, and the displacement dx dt is equals to v. This is the velocity. Then our acceleration is equals to the derivative of the velocity. So we have the velocity as 60. We have the velocity as it is here, t squared minus 60. So our acceleration A is equals to dv over dt, which is d of t squared minus 60 over dt, which is with respect to time. This with respect to time, we said we are multiplying this to 2t because you have minus 1 here, and this becomes minus 6. So we are told at t is equals to 2 seconds, we are going to replace t with 2. So it will be 2 into 2 minus 6, that is 4 minus 6, that is minus 2 per second. That is the final answer. Hope you have understood. That is the calculus differentiation. So we are going to look at the part of integration on our next question. So I hope you have understood very well. That was of my time. Thank you very much, and welcome to Max Makes Maths Easy.